Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In this session, we are going to deal with one of the continuous distribution, normal distribution, in continuation with the previous session. Already we have dealt with the normal distribution, wherein we have discussed the moments, definition, and some of the properties of normal distribution. Continuing the normal distribution study, in this session we are going to deal with some more problems in normal distribution. And in continuation with the continuous distribution, we are also going to deal with another distribution called as uniform distribution, and its moments will be discussed. Some problems will be discussed derived in uniform distribution to understand the concept further. Normal distribution, we will do one example where the example goes like that. In a distribution exactly normal, 10.03% of the items are under 25 kilograms weight, and 89.97% of the items are under 70 kilograms weight. What are the mean and standard deviation of the distribution? In the previous session, we have dealt with a problem in normal distribution, wherein the mean and standard deviation of the distribution will be given, and you will be asked to find out the area covered by the standard normal curve, whereas you are being asked to find out the probability. But here the discussion is entirely different, wherein you are being given the area covered by the 25 kilograms weight and area covered under 70 kilograms weight, and you are asked to find out mean and standard deviation, which is reverse to the previous problem discussed in previous session. Let us see how the problem goes. We have to find out the mean and standard deviation of the distribution. Okay. For any problem, we have to go to drawing the standard normal curve. Okay. First of all, we will shade the area of 10.03% of the area which is covered under 25 kilograms weight. To find out the mean and standard deviation of the distribution, first of all we should draw the area covered by the percentage given. First of all, we have to plot the area covered by 25 kilograms weight, and this particular area is given to be equal to 10.03%. Since half of the area is 50%, what will be this particular area? That will be 50% minus 10.03%, which is equal to 39.97%. Okay. So, the information given as 10.03% are under 25 kilograms weight has been drawn in the standard normal curve. What is the next information given in the question is 89.97% of the items are under 70 kilograms weight. So, we shall draw this. Are under 70 kilograms weight means we have to plot this here, x is equal to 70, and this particular area fully, I will just put it in the dot, and this dotted area is given as 89.97%. The dotted area covers almost half part, that is 50% is already covered by this. So, what is this particular area which I am showing in the diagram? This particular area will be 89.97% minus this half, I will take it off 50%. So, the remaining is 39.97. This drawn with vertical lines, this particular area is 39.97%. Okay. Because all the standard area standard normal curve area given in the standard normal tables is only from x is equal to the mean mu. X is equal to mean mu means standard normal variable z is equal to 0. All these has been given from z is equal to 0. That is why we are plotting this area adjacent to the line z is equal to 0. Okay. And based on these x is equal to 25 and x is equal to 70, we have to find out the corresponding z values. Since x is equal to 25 is on the left of z, we have to take z is equal to minus z1. We do not know what is this value, we have to find out. And since x is equal to 70 is to the right of z is equal to 0, we have to take z as z is equal to z2. We have to find out this z1 and z2. Why this is marked as minus z1? Because it is on the left of z is equal to 0. Okay. With this information, we will go ahead in finding these two z values, and after finding that we will get two equations. Solving the two equations, we will get mean and standard deviation of the distribution. From the tables, normal, standard curve tables, we have found out the P of 0 z less than 1.28 is equal to 0.3997. This area is 0.3997, right, and this area is also 0.3997. Okay. So, this is from normal tables. So, therefore, this z value will be z is equal to minus 1.28, because this is from 0 to minus 1.28 is 0.3997, because the area is symmetric. Minus area from 0 to 1.28 is same as the area from 0 to minus 1.28. So, we have found out the z value as 1.28. If x is equal to 25, z is equal to minus 1.28. This is from the diagram. And if x is equal to 75, z is equal to 1.28. And using the conversion formula, z is equal to x minus mu by sigma, we have two equations. Substituting corresponding x value and z value, minus 1.28 is equal to 25 minus mu by sigma, and another information based on x is equal to 75 is 1.28 is equal to 75 minus mu by sigma. This equation gives minus 1.28 sigma is equal to 25 minus mu, and this information gives you 1.28 sigma is equal to 75 minus mu. We have to solve these two equations. Solve these equations by first subtracting. We get mu gets cancelled, and you have minus 2.56 sigma is equal to 50 minus 50. So, sigma is equal to 17.578. This is sigma value. Substituting the sigma value anywhere, we get mu is equal to 47.5. Okay. Hence, we have found out mean and standard deviation of the distribution. We have found out the mean and standard deviation of the distribution. Hence, this problem is over. Okay. Next, we will discuss some additive property of normal distribution. What is the additive property of normal distribution? Says that is, if x1 follows normal distribution with the parameters mu1 and sigma 1. Mu1 is mean and sigma 1 is standard deviation of this distribution. Similarly, x2 follows normal distribution with mu2 comma sigma 2, etc. xn follows normal distribution with mu n comma sigma n. All these random variables are independent random variables. Okay. Then what happens to its addition? x1 plus x2 plus etc. plus xn follows normal distribution with mu1 plus mu2 plus etc. plus mu n, comma, what is the standard deviation? Root of sigma 1 square plus sigma 2 square plus etc. plus sigma n square. This particular property can be arrived based on the moment generating function of normal distribution. So, this is the additive property of normal distribution. Now, based on additive property of normal distribution, this example can be discussed. What does the example says? The marks obtained by the students in mathematics, physics and chemistry in an examination are normally distributed with means 52, 50 and 48 and with standard deviations 10, 8 and 6 respectively. Find the probability that a student selected at random has secured a total of 180 and above. Why this particular subject has been chosen? Mathematics, physics and chemistry. Because in any engineering admission, these three subjects only we will have a cutoff. Earlier it was like that. Mathematics, physics and chemistry. So, the total, if it is 180 and above, what is the probability that the student will be selected? And if the total is less than 135, what is the probability that the student selected will have the chance to get an engineering admission? Let us see this. Okay. So, narrating all the informations mathematically, the solution goes like that. What is the first information given? Mathematics. We call the max variable as x1. x1 follows normal distribution with the mean 52 and standard deviation 10. Next is physics. We call the physics random variable as x2, follows normal distribution with mean 50, standard deviation 8. Next is chemistry. x3 follows normal distribution with mean 48 and standard deviation 6. What is the total? Total of these three subjects is x1 plus x2 plus x3. According to the additive property, it will follow the normal distribution with parameters 52 plus 50 plus 48 comma root of 10 square, standard deviation is 10 square plus 8 square plus 6 square. That is, the total T is equal to x1 plus x2 plus x3 will follow normal distribution with mean 150 and standard deviation 14.14. What is the first question? What is the total? Total will exceed 180. Okay. This is first question. We have to answer to this converting the variable t to the standard normal variable z using the information z is equal to t minus 150 by 48. Okay. If t is equal to 180, what is the standard normal variable changes as 180 minus 150 by 14.14. This is equal to 2.12. P of t greater than 180 implies P of z greater than 2.12. As already known, for finding the probability in normal distribution, we have to draw the standard normal curve, plot the point z is equal to 2.12 and shade the area greater than 2.12. This is what is asked. From the question given, what is the probability of P of 0 less than z less than 2.12. This area from the table is given as 0.4830 from the tables. This is, that is, P of 0 less than z less than 2.12 is equal to 0.4830. This is from the tables. You must be having the standard normal tables for doing problems in normal distribution. So, what is the required area? Required area is P of z greater than 2.12 is equal to 0.5 minus 0.4830, which is equal to 0.0170. Okay. What is the next question? What is the total? It will be less than 135. Similarly, doing, if t is equal to 135, z is equal to 135 minus 150 by 14.14. So, this z value is minus 1.06. So, P of t less than 135 means you have to find out P of z less than minus 1.06. What is it equal to? Again draw the diagram, plot z is equal to minus 1.06, shade the area, this particular area is asked, and this area from the tables will be 0.35554, that is P of 0 less than Z less than 1.06. Based on the symmetricity, it is same as 0 to minus 1.06. Okay. This is from the tables. Okay. So, what is the required area? Required area is P of Z less than minus 1.06 is equal to, from half minus from 0.5 you have to subtract this 0.3554. What is this equal to? 0.1446. Hence, we have found out the probability that the total will be greater than 180 and above. The answer is 0.0170, and the probability that the total will be less than 135 is 0.1446. So far, we have discussed the normal distribution, wherein we have discussed the definition, and some problems have been worked out, finding the mean and standard deviation. Based on additive property of normal distribution, we have discussed also a problem. And next continuous distribution is uniform distribution. What is a uniform distribution? Definition says, a continuous random variable x is said to follow uniform distribution in any finite interval if its PDF is a constant in that interval. For prescribing the uniform distribution, you must always prescribe the finite interval where it follows. That is, if x follows normal uniform distribution in a less than x less than b, this interval is very important. Based on this interval only we have to find out we have to write its PDF. Then f of x is equal to 1 divided by b minus a in the interval a less than x less than b. Always after discussing the definition, we will find out the moment generating function and moments. So, first of all we will find out the moments of uniform distribution. What is the moments formula? Mu r dash is equal to expectation of x power r. Since this is a continuous distribution, we have the integration x power r into f of x dx. Here f of x is 1 by b minus a for a less than x less than b. So, mu r dash is equal to integral a to b x power r, f of x is 1 by b minus a dx, and 1 by b minus a is taken outside, x power r plus 1 by r plus 1 within the limits a to b. After substituting and cancelling, we have the formula as b power r plus 1 minus a power r plus 1 by r plus 1. This is mu r dash, rth moment of uniform distribution. Based on this you can find out mean. What is mean? Mean is mu 1 dash, mu 1 dash. So, put r is equal to 1, we get mu 1 dash is equal to b square minus a square. Mu r dash is b power r plus 1 minus a power r plus 1 into b minus a. And b square minus a square into 1 plus 1 is 2 into b minus a. Using the formula of b square minus a square as b minus a into b plus a, we have b plus a by 2. So, what is mean of a uniform distribution? Mean is equal to b plus a by 2. Then central moments. Based on central moments we can find out the variance. The central moments formula is mu r is equal to expectation of x minus e of x whole power r. This is x minus what is the mean of uniform distribution is b plus a by 2 whole power r. Limits is x is equal to a to x is equal to b into f of x dx. F of x also we will substitute here itself. F of x is 1 by b minus a. Okay. After careful evaluation by substitution method, t is equal to x minus b plus a by 2. Okay. Then x is equal to a implies t is equal to minus 1 by 2 into b minus a, and x is equal to b implies t is equal to 1 by 2 into b minus a. dx is dt is dx. Substituting all these values, we have integral t is equal to minus 1 by 2 b minus a to t is equal to 1 by 2 b minus a t power r into dt, and this integration goes as 0 if r is odd, and it is 1 by r plus 1 into b minus a by 2 whole power r if r is even, based on the properties of definite integrals. This is mu r, right, central moments. Variance is mu 2, second central moment. So, put r is equal to 2, and it r being an even number, we have to substitute here only, that is 1 by 12 into b minus a whole square. This is variance. Hence, we have found out mean and variance of a uniform distribution. Okay. We will do a problem in uniform distribution so that you understand the concept further. Buses arrive at a specified stop at 15 minutes interval starting at 7 a.m. At 15 minutes interval means they are arriving at one bus arrives at 7 o'clock and another bus arrives at 7:15, then 15 minutes interval means 7:30, 7:45 and so on, morning a.m. And if a passenger arrives at the stop at a random time that is uniformly distributed between 7 and 7:30 a.m., find the probability that he waits less than 5 minutes for a bus and at least 12 minutes for a bus. Okay. So, two problems we have to do. Let us see how that it goes. Already it is given, if we take x is a uniform distributed random variable, then x follows uniform distribution between 7 and 7:30 a.m. So, we have to specify the random variable as x is the time, x denotes the time in minutes past 7 a.m. Okay. When the passenger arrives at the stop. The passenger arrives at the stop between 7 and 7:30 a.m. only. Therefore, x follows an uniform distribution between 0 and 30. We have to talk only about the minutes 0 to 30. So, x follows uniform distribution 0, 30. So, what is your PDF? F of x is equal to 1 by 30 minus 0, 1 by 30 minus 0, 0 less than x less than 30. Okay. The passenger will have to wait for less than 5 minutes, which is first subdivision. The passenger will have to wait for less than 5 minutes if he arrives at the stop between 7:10 and 7:15 a.m. This is one possibility to catch the 7:15 bus, or 7:25 and 7:30 a.m. to catch the 7:30 a.m. bus. Okay. So, required probability is P of 10 less than x less than 15, or means you have to add P of 25 less than x less than 30. So, this is 10 to 15 1 by 30 dx plus 25 to 30 1 by 30 dx. Integrating and substituting the values, we get 1 by 3. The second is he has to wait for 12 minutes, at least 12 minutes. At least 12 minutes means, for example, 12, 13, 14 minutes or 15 minutes. 15 minutes means he will get another bus. If he arrives at the stop between 7 a.m. and 7:03 a.m., then only he will wait for more than 12 minutes. Or for 7:30 bus, he will arrive at 7:15 a.m. and 7:18 a.m. So, based on this, the required probability is P of 0 less than x less than 3 minutes. plus P of 15 less than x less than 18. Okay. So, integral 0 to 3 1 by 30 dx plus integral 15 to 18 1 by 30 dx. After careful integration, the answer is 1 by 5. In this session, we have dealt with a normal distribution problem wherein you will be asked to find out the mean and standard deviation, where the area is given, and then based on additive property of normal distribution we have done a problem. Also, in continuation with the continuous distribution, next distribution, uniform distribution was discussed. That is, the definition was discussed, the moments of the uniform distribution was derived, and a problem was worked out in uniform distribution to understand the concept very clearly. Based on the discussions in this session, you can do this exercise on your own. That is, in a normal distribution 31% of the items are under 45, that is, plot the point x is equal to 45 and shade the area 31%, and 8% of the items are over 64. Similarly, 8% has to be shaded and plot 64. Find mean and variance of the distribution, that is, find mean and standard deviation. Using standard deviation, find the variance. And another problem is based on the uniform distribution. A radio station broadcasts the correct time every hour on the hour bulletin in the hours of 6 am and 12 midnight. What is the probability that a listener will have to wait less than 10 minutes to hear the correct time if the time at which he tunes in is distributed uniformly over the interval 6 am and 12 midnight? That is, the interval is getting changed, so your PDF will get changed here. Okay, the question is only one. You have to find out the probability of less than 10 minutes. The person has to wait for less than 10 minutes, but the PDF will change based on the interval 6 am and 12 midnight for the first question. Second question is 8 am and 6 pm. Collect only the interval hours between 8 am and 6 pm. Similarly, 7:30 am and 5:30 pm. Count only the hours and convert into the PDF. Okay. This exercise can be done on the one of the exercise done in uniform distribution. Thank you.